So yeah, at the last open source conference, I was talking about how I built this, which is a fully custom ergonomic keyboard I built from scratch. And today, I'd like to talk about how that turned into a whole general purpose keyboard declaration language and a community of hundreds already around it. And in the meantime, hopefully make you all a bit interested in the custom keyboard rabbit hole. So just for a quick refresher, so that we all start with the same common ground, I started with the same cheap plastic rectangles that most of us use, but as a kind of graduation present for myself, I wanted to upgrade to mechanical switches, because if I'm tapping away on something for 10 to 12 hours a day, I might as well be tapping away on something more comfortable and high quality. But this just opened the floodgates, because while I was replacing my switches, I actually realized that I could even rearrange my switches to be in more natural and comfortable positions. So I started by leaving off the numpad, but I also then left off the navigation cluster and the F keys, and then even the number row. And then the leftover keys I then laid out according to how my fingers are actually laid out. So this led to this build right here, the Absolem. So most of these changes existed already in the wild. What I consider my minor addition to the state of the art is just a strict adherence to what I've been calling the one distance from home principle, meaning that you don't have to wander away more than one step from your home position with your fingers. The others are merely just a collection of best practices from all over the spectrum. So yeah, this is the Absolem build. What we need to know about this for today's presentation is that I needed 2D shapes to the laser cutters in order to be able to manufacture it. And I refused to design these shapes by hand because I'm a programmer, so I'm not doing things, I'm making computers do things. So I wrote some code which then generated these shapes for me. After completing this project, two things became very clear based on mostly community feedback. One is that what's ideal for me, measurement-wise, can be very suboptimal for others. So this whole column stagger philosophy is just basic human anatomy applied. So that part's solid, but apart from that, the display amounts, the stagger amounts, the spacing between the keys and stuff like that, these are all highly personal decisions. And the other thing I realized is that I don't ever want to do a handwire project ever again if I can help it. Because it was quite the nightmare. So if I wanted to upgrade my generator script, I needed to add some PCB or printed circuit board capabilities. In short, what I realized is that if I wanted to help the community, instead of defining the N+1th one true board design, I should really be making it more easier for others to define their own individual one true board designs. So yeah, the goals are mostly exactness. The target audience for this is people who want to build their own custom designs but can't really use CAD software more in depth. Or they could, but they are not familiar or they're not comfortable with eyeballing things through a point-and-click graphical user interface. So they want exactness, which is the main goal, partly due to my minor OCD. But then to this, I've added the goals of ease of use and generalizability. Generalizability, because of all the feedback that I've been getting, and in order to support others in being able to design their own endgames, and ease of use to actually make this endgame description declarative, so that no one needs actual programming experience to be able to use this. So this is what turned out after some rewrites into what is known today as Ergogen. And let's talk about what it can do for you. So at the most basic level, Ergogen is about laying out points on a plane. So in this context, a point is the usual xy coordinates plus an added rotation r, because keycaps are usually not independent of rotation. So as well as the position, you need the orientation of the keycaps. Now, for minor, easier projects, it could be viable to just simply list x, y, and r coordinates to lay out your points, but Ergogen makes it easier for you by using zones which are made up of columns, which are in turn made up of individual points. The decision to make it column-based instead of row-based is very intentional, because the Ergogen is just a contraction of ergonomic generator, if this wasn't obvious enough, and the ergonomic part in the name refers to how it's opinionated about being column-based layouts. It can be forced to do row-based layouts, but that's really not the point of the tool. So after you lay out your points in a zone-based configuration, then you can use that to create 2D shapes and 3D printable models, and then also PCB scaffolding based off of those. But for a concrete example, not to get lost in the theory, we should look at how something like this, the Absolem, should be laid out through this config language. So the actual syntax we'll be using is just YAML, or yet another markup language, but it could also be JSON or any code that generates JSON. So it's basically just an object. The magic lies with the fields that we define and how they define them. So in this basic example, we just say that we declare a zone called matrix that has 5 columns and 3 rows, which is laid out from left to right and from bottom to top, as the order might suggest. And if we input this to the program, we get the 3x5 matrix on the right. Simple enough yet. Now, if we want to make it more Absolem-y, we could continue by adding the stagger amounts, which we can do by these attributes called stagger, the 12, 5, -6. These are added cumulatively, so it leads to this kind of stagger between the columns to mimic the different finger lengths. Yeah, and if we also want to add the signature pinky rotation of the Absolem, we can do so by introducing rotation and origin, which are also key-level attributes like the stagger that we used previously. So with it, we add, so the pinky is just the plain pinky column, but at the ring, we add an extra 5 degrees of rotation with the bottom left hinge, so it changes everything else that comes after that. And this is how the pinky is separate from the others. Yeah, at this point, I think it's time to mention anchors, which are another way to define points even more easily if rotations are involved. So this is more of a Jack and Jill kind of following the breadcrumbs method of defining points. So you're not directly saying where you want the point to be, you just say how it can be reached through one or even multiple steps of rotations and shifts. So with these anchors, we can actually position another zone, thumb fan, which can be shifted from our matrix inner bottom, which is just a reference to this key, 7 to the left and 1 keycap unit to downwards. And there we can just add 3 more keys to add the thumb keys. And if we add the now familiar, the now familiar rotation, please go back 1. Okay, so the now familiar rotation leads to this thumb fan, which just mimics the thumbs moving along an arc. So this is the left half, practically done. If we want to finish with the right side, we just need to add a more intense inter-half angle by adding an extra 15 degrees of rotation to the whole matrix column, which added to the pinky's 5 is a total of 20 degrees inward. And then we just declare a mirror clause that states that the matrix pinky home, which is this key, should be 223 millimeters away from its mirrored counterpart. And all the rest is just automatically calculated and the whole zones are mirrored. So this is how we get to lay out like this. I don't know if the camera can see it. Now these are just the points. And now we can move on to what these points enable you to do. The most important probably is outlines, where you can lay out all of these points on both sides and say how big of a rectangle you want and with how much of its column or corner, sorry, chopped off. So yeah, these are 36 by 36 rectangles, which can be specified like this because expressions are also okay wherever numbers are expected in the config. And they are also combined together, so we get to these two shapes, which are really similar to what I've showed before. The only problem is that they're in two parts still. So if we want to glue them together, we can do so by specifying another shape, a polygon, whose points can be anchors themselves. And if we specify the operation to be stack, so this is the combination operation, and it just shows them one on top of the other. This is useful for debugging or checking if the shape itself is correct or how we want it to be. And if it is, then we can just simply change the combination operation to the default add, which then melts the shapes together and leads to this shape right here. Now, if we want to further refine this, we can use existing outlines like this plate one that we just defined as starting points for other shapes. For example, if we define the filleted shape, that can use the plate outline and add an extra fillet operation of 2, which means just the rounding of the remaining hard corners by a 2 mm radius. And finally, if we subtract from this the original key positions, or more precisely, if we lay out 18 by 18 squares for the keycaps at each position and then subtract that from this shape, then we get a file that is remarkably similar to what I submitted to the laser cutters when I tried to get this made. So this is it for shapes. 3D support is pretty rudimentary at this point still, but if all we need is just an extrusion of existing outlines, then we can do that simply by defining a case where we choose an outline and an extrusion amount, and then it creates a printable 3D object for us if our manufacturing process doesn't involve laser cutting and we rely on 3D printing, for example. And now for the main payoff of defining points, which is PCBs. At least according to feedback I've been getting, this is the main use case of people using Ergogen, is to get generated PCB templates, which it does by integrating with KiCad, the de facto standard of printed circuit boards, at least in the open source world. So if we consider these points that we define as potential places to put footprints, component footprints of the PCB, and then we want to reuse outlines to act as the edge cut of the PCB, then we are practically done. So we can define footprints by adding them to the points. Here we define a switch one whose type is MX, which is just the regular mechanical switch MX standard. And it just puts an MX switch footprint at every point. And then we can also declare its net connections right in the configuration, so it knows what it should be connecting to. In this simple case, it's just a direct wiring, so the from block is connected to each key's name. The equal sign means that it's read from the key where it's laid out, so each individual key gets its own individual net, and the to block is just connected to the common ground so that the controllers can read low on the pins to detect key presses. This is for footprints, and for defining the PCB itself, we just define a block like this, where we reuse the filleted outline from earlier as the edge cuts layer for KiCad. We use the key footprints by default, and then we can also declare additional global footprints like this Pro Micro, which is a reference to the most common microcontroller, Arduino's Pro Micro, that gets laid out at the center of the board. And if we do this, then we get a KiCad PCB output that looks like this when rendered with all the potential nets, so these are the grounds connected. And it's also 3D rendered like this, so all we need to do further is to actually route this PCB and off to the manufacturer as it can go. So yeah, don't worry if this all was a bit quick or dense or stuff like that. It was just an overview of what Ergogen can do for you if you want to define your own ergonomic layout. Yeah, if you want to experiment with it or try it out, you can access it through GitHub. It's all open source, MIT license. It supports both command line interface workflows as well as a web user interface that's accessible at ergogen.xyz. At least that's the official one. And now we have a contribution one thanks to generous contributor Cash, which is even better than the official one as shown up here, supporting live previews and stuff. So you can even try that first as a beginner. It's much easier there. So you basically just read the documentation to get to the configs that I've just shown. Don't worry, I had to check my own documentation 5 minutes per example to be able to check or prepare them. But once you know what you want to do, you can just write a pretty small terse config on the left, get previews in the middle, and your file downloads on the right, which you can just directly submit to the laser cutters, the 3D printers, and the PCB manufacturers. You then just get a few switches and a soldering iron, build your own board, become a happier and better person. Piece of cake. Yeah, so that's about it from the technical side, and now on to the community that has sprung up around it. Because when I wrote it, I expected about 3 to 4 users max. So the fact that it just passed 250 stars on GitHub is a daily source of heartwarm for me. And also the hundreds on the Discord server, the Absolem club Discord that has sprung up around this as well. And we are full of people who are using Ergogen and are also contributing a lot of extra open source goodness to the interface design community. So let me just show you a quick overview of what's happening there. So this is popular YouTuber and also unofficial Ergogen mascot, Ben who builds these minimal wireless split boards. He has this column staggered one called the flipper and this ortholinear one called the card, which are all generated using Ergogen and then a lot more post-processing and routing in KiCad. There's also Toppy, who holds the most Ergogen boards defined per unit amount of time record. He basically just did these in a few weeks. Yeah, and he did a bunch of these squid-tamed boards in his cephalopoda repository, and we can all have access to these as well. The ADAX is really popular. And also giving us a glimpse into the future is Soundmonster, whose Samaklova repository even bridged the last remaining human interaction bit because it just defined a fully automatic GitHub workflow that runs Ergogen and then runs the resulting PCB through an auto router, a topological auto router that actually outputs a fully complete PCB for manufacturing. But this is just the tip of the iceberg. I could literally go on and on and on. These are some of the boards that the community members have built using Ergogen. These are all completely functional and built and open source. I believe all of them are open source, yeah. And also another unexpected plus side of this community is that we also interact with a lot of people who are contributing their own way. So they're not Ergogen users per se, but they contribute a lot of stuff. Like we have these 2.5D builds, which are not exactly 3D keyboards, but they use these PCB material bits to scaffold the keys to make these key valves more three-dimensional, and also some hardware hacks to be able to include joysticks and pointers and ink screens, displays, trackpads, trackballs, what have you. We also have these switch modders who actually take apart and lube and mod and tape the switches so that they sound and feel just as good as they can. 3D modelers who actually design their own keycap profiles with custom surfaces and sizings, and even layout designers who actually help with the ergonomics factor on the software side by laying out letters that typing experience can be as good as it can be. Also, shout out to PJ Hansen and his team who completely shoulders the firmware part of the equation by contributing ZMK so that the rest of us can focus on all these wonderful hardware experimentation stuff. So I see that I'm pretty much out of time, so just a really quick future. I intend to write some documentation, better test coverage, footprint bundling, better 3D modeling, so plans are not in short order. To paraphrase Bilbo Baggins, I know half of these projects half as well as I like, and I can devote half as much time to half of my projects as I can, but plans are not in short order. So I intend to keep developing it and keep building the community around it. So that's it. Thank you all. You can find me at any of these links. If you find this interesting, consider joining us on Discord. And yeah, s'mores are overrated, trains are lame. Thank you. I'm open to questions.
Thank you, Dénes.